Hi, it's time for another math. Easy. So we're going to discuss, well, just basically some problems plus example. Basically, look at this one here. In my calculus book, it has these problem plus after each chapter, which are pretty interesting and it gets you thinking. So basically, this example, basically x squared plus 1 times y squared plus 1 times z squared plus 1 all divided by x, y, z. Basically, it's saying prove that this is greater than 8 here. So basically, what you're supposed to do in this one, this looks really complex here. The idea that the calculus book's trying to get is trying to simplify complex equations. Yeah, because this one is pretty complex here, and also what you got to do is basically break down into similar and simpler terms. And in this case here, although it looks complex here, as you can see here, if you rewrite this one so that the x is it will be inside one little bracket here, so we'll have x squared plus 1 over x. So if you just rewrite it like this, you can see that it's easier to understand here and to grasp. So it'll be z squared plus 1 over z greater than equal to 8 here. And as you can see, these are all the same equations, but just different variable here. So if number 8 here, imagine, so all we have to do is actually just think about this one separate one. If this is over x, if we prove that this is greater than 2, so this all we need to do, if we can prove this, then basically we'll have proven this this function here gets into, this will just be 2 times 2 times 2 and greater than 8. Yeah, so we have to try to prove this, and then once again, if you do prove it, if this is greater than 2, will be a 2 times by 2 times by 2, and these will all be greater than 2, and that would be all greater than 8 here, because 2 times 2 times 2 is 8. So that is basically the idea that the calculus book is trying to get, is trying to simplify this. So now we have to just solve the simpler problem instead of looking at this here. And you could do it two ways here. You could either use calculus, consider this as f of x is equal to x squared plus 1, and you're just trying to minimize or maximum, yeah, basically minimize the function here. And this is equal to, we'll just divide it out, x plus 1 over x here. And if you take a derivative just to find out what the minimum is, so the derivative in this case is going to be 1 plus, or just minus 1 over x squared here. And like always, you have to get the critical points, set this equal to 0. So f of x equal to 0, solve for x will be 1 minus 1 over x squared. Rearrange it, 1 equals 1 over x squared. Put this on this side here, and then you're going to have x squared is equal to, yeah, x squared is equal to 1 here, and then solving for x is equal to plus or minus 1. But I forgot to mention actually in this one here, this is for basically for x, y, and z are greater than 0. So I forgot to solve this one. I mean greater or equal to 0, so it could be greater than or equal to 0. So just get back to this one. Since it's greater than or equal to 0, we only look at the positive one here, so it's equals to 1 here. So this is the critical number here. And then, as you can see from this one, yes, since f prime of x here, this, regardless of what value here, if you put 1 here, you're going to get 0. But if you put anything above, because it's 1 minus, this number here is going to be less than equal to, yeah, basically less than equal to 1. 1 is the maximum. In this case, if you put infinity, it's going to go to 0. So then, this f prime of x is greater than equal to 0. So it's always increasing. So it's always increasing, then at the critical point is going to be the minimum here. So then at f of 1 is equal to minimum, in this case, we just plug this in. And this equals to, well, number x plus 1 over x, that's just going to be 1 plus 1 over 1 equals 2. So 2 is the minimum. Thus we've proven that basically f of x equals to x squared plus 1 over x is greater or equal to 2 here. Because remember, it's just a minimum, finding the minimum problem here. So if we've proven this one, then we've proven this as well, because every single one's the same. And then this is going to be greater than 8 here. And also, you don't even need to use calculus to prove this, actually. You could have just done, if you had something like this, x squared plus 1 over x. If you were to prove this one, all you could do, you could just simplify this one, multiply x on both sides. So if x plus 1 greater than 2x, and then rearrange this, you're going to have x squared minus 2x plus 1 is greater than 0. And to see if this function, if you break it down, because this is a perfect square here, so this is just going to be x minus 1 squared if you factor it out. I'll show another video on factoring, but basically if you factor this out. If you multiply this this out, you're going to get this one here. And this is greater than 0, and this is greater than 0. This is true here because if x is greater than equal to 0, if you put in 0 here, you're going to have negative 1 squared, which is 1. And then if you put in anything greater than 0, it's always going to be true. So if this is true, then this is true as well. So you could kind of go reverse kind of like that. So this is true, and then if this is true here, since these are the same functions, different variables, every single one is greater than 2, and then everyone's going to be greater than 8. So that's a proof for this one. Hopefully you learned about this. Just a fun little example to get you thinking and breaking down complex equations. And yeah, remember you can always download these notes and Dropbox link below. If you learn, and stay tuned for another math easy solution.